Today, on how it's made. Cement. Just the hard facts. Caskets. Talk about a dead-end job. Soft drinks. A foray into pop culture. And glider rockers. We visit a chair factory that gets into the swing of things. Many people confuse the terms cement and concrete. Cement is a fine gray powder that's used to make concrete. It's also an ingredient in the mortar that masons use to lay brick and stone. Cement also goes into soil cement, a material that's used in paving roads, building dams, and lining reservoirs. The action begins at the limestone quarry. The limestone near the surface has a high content of the minerals silica, iron, and aluminum oxide. Deeper down, the limestone is more pure, containing less of those minerals and more calcium carbonate. The plant uses both types of rock, altering the proportions to make different types of cement. Workers drill holes in the rock wall in which they plant powerful explosives. For safety, the workers have to position themselves behind the area they're blasting, maintaining a distance of at least 50 meters. After the explosion, loaders move in. They transfer the limestone rocks to 50-ton capacity dump trucks. The trucks then haul their cargo to the cement plant nearby. At the plant, the trucks dump the rocks into what's called the primary crusher. The rocks can be as big as a piano. The primary crusher reduces them to about the size of softballs. There's a constant spray of water to keep the dust from billowing up and settling on the chutes. From there, a conveyor transports the rocks to the secondary crusher. It reduces them further to about the size of golf balls. Rock high in calcium carbonate and rock low in calcium carbonate are crushed separately. Now it's time to mix the two. The ratio varies according to the type of cement they're making. This overhead machine called a tripper makes piles of the required proportions. They call this the raw mix. Then a reclaimer loads the raw mix into a grinding machine called a roller mill. Depending on what minerals are already naturally in the crushed rock, the factory adds extra minerals such as silica and iron. Certain types of cement also require aluminum oxide. The roller mixes and grinds the ingredients uniformly, producing a dry rock powder called the raw meal. Now the powder goes into a preheater. The temperature of the powder is 80 degrees Celsius upon entering. Within 40 seconds, it gets more than 10 times hotter. This begins the process of bonding the minerals together so that they'll later harden when hydrated with water. The preheater is equipped with what's called a flash calciner. In about 5 seconds, it removes 95% of the carbon dioxide in the powder through a chemical reaction. This isolates the lime, which is the most important element in cement. From there, the powder moves into a rotary kiln, a huge cylindrical furnace. It's set at an angle so that the powder moves from top to bottom a distance of 49 meters. The kiln rotates about 2 turns a minute to ensure the material travels through at the right speed. The burner's gas flame at the bottom reaches a scorching 16 to 1700 degrees Celsius. As the powder approaching it reaches the 1500 degree mark, it fuses into pieces about the size of marbles. These pieces are called clinker. As the clinker leaves the kiln, large fans cool it down to between 60 and 80 degrees Celsius. It's important to cool the clinker quickly in order to have quality cement. From here, the clinker goes to the storage area. The The last stage of cement making is called finish grinding. They add some gypsum to the clinker. The precise amount varies with the type of cement they're making. Gypsum delays the cement's setting time so that it can be worked for up to 2 hours before hardening. The cement mills are called ball mills because they contain metal balls, about 150 tons of them in the largest mill. As the mill rotates, the balls crush and grind the clinker and gypsum into a fine powder. The terms casket and coffin are often used interchangeably, but their use as synonyms is no open and shut case. Coffins are actually those 8-sided burial boxes that are narrower at the bottom. Think Dracula. Whereas caskets are rectangular. They can be made of metal, plastic, or wood. Whether the wood is ash, oak, mahogany, or something else, the casket's construction is generally the same. First, they run wood slats through a machine called a molder. This profiles the edges, carving a tongue on one side of each slat and a groove on the other. A worker applies glue to these edges, then positions the slats in a rounded vise that locks the tongues and grooves together. The glue dries in an hour and a half, bonding the slats permanently into a large curved piece. This piece will form the top and long sides of the casket's rectangular cover. To complete the rectangle, a worker now makes a V-shaped cut on each side and glues in a triangular piece of slatted wood. While a press clamps the components tightly together, he secures the end pieces in place with joint fasteners, which are like heavy-duty staples. Now a machine carves a groove into the cover's underside at the midpoint. A worker glues in a wooden piece, securing it with joint fasteners. This piece is called the bridge, and it's the point at which the cover will be cut in half later on. They transfer the casket cover to an automated machine that gives it a rough sanding, then a finer sanding. The next step is to attach a decorative molding to the base of the casket cover. This molding has a groove on the inside into which they'll later tuck the edge of the casket's upholstery fabric. A worker glues a small piece of wood in the groove at the midpoint so the groove won't show when the cover is open. Now he saws the casket cover in two, right through the bridge. Meanwhile, another worker assembles the bottom of the casket called the box. He glues together the sides and applies a bottom molding, securing everything with joint fasteners. At this point, the box is upside down. He attaches the bottom, then flips the box right side up. Now it's time to join the cover and box using 4 hinges. They spray the casket with one of countless shades of wood stain, then rub it in equally over the entire surface. The casket goes into an oven for an hour to dry the stain. Next, a worker sprays on 2 coats of lacquer with 40 minutes drying time between applications. This happens to be a high-gloss finish, but many models have a duller sheen. Once the lacquer dries, a worker attaches handles. The more expensive the casket, the fancier the features. This higher-end oak model with decorative corners has wood and metal swing handles. Other models have all-metal swing handles or fixed bars made of wood, metal, or both. The fancier caskets also have an adjustable wooden bed inside with a mechanism to adjust the height. A worker covers the bed in fabric. The base model bed is made of absorbent paper laid over a product called wood wool, which is simply shredded wood. The upholsterer lines the inside of the casket with foam, covering it with either velvet, satin, or silk polyester crepe. By folding, nailing, and stapling this fabric a certain way, she creates pleats, tufting, and other design details. Generally, the more expensive the casket, the finer the fabric, and the more ornate the upholstery. A decorative trim hides the staples. Fabric straps or metal elbow brackets hold the cover open. When it comes to how beautiful and elaborate caskets can be, the ground's the limit. The soft drink was born at the drugstore soda fountain, where pharmacists would serve up various flavors of carbonated water, initially considered a medicinal drink. These sodas became so popular that customers wanted to be able to buy them in bottles to take home. That demand spawned the soft drink industry. In 2003, almost 195 billion liters of soft drinks were sold around the world. That's 30 liters for every person on Earth. These 2-liter plastic bottles have just arrived from the bottle factory. Even though they're brand new bottles, the soft drink plant still has to clean them before filling them. This rinsing machine turns the bottles upside down, then flushes them with water the plant filters on site. Once the water drains out, the machine turns the bottles right side up again, and they make their way to the filling station. Meanwhile, in the mixing room, technicians prepare whatever soft drink they'll be bottling in this production run. Each recipe begins with filtered water. It makes up 86% of the drink. The rest is syrup. Each syrup recipe is a combination of carefully measured ingredients, natural and artificial coloring and flavoring, and one or more of various types of sugar, such as glucose or fructose, extracted from beets, corn, or cane. This machine releases the right proportion of syrup to filtered water, creating the final soft drink minus the bubbles. The drink now travels to a pressurized tank called the carbonator. There, an injection of carbon dioxide infuses the drink with gas bubbles. The carbonated soft drink now travels to the reservoir of the bottling machine. The bottles arrive and travel its carousel. The machine removes the air in each bottle, then fills it with, in this case, 2 liters of cola. Now onto the capping machine. The caps come down a chute propelled by filtered air. The machine twists a cap on the part of the bottle called the crimp, intertwining the threads of the cap and crimp tightly to hermetically seal the bottle. Next stop, labeling. The machine's roller applies cold glue to one metal plate after another. Each plate then grabs a label and applies it to a bottle. Brushes smooth edges down, ensuring the labels adhere well. Elsewhere in the plant, a machine called the uncaser unloads cases of refillable glass bottles that have come back to the factory. The cases continue toward a case washing machine. The dirty bottles head toward the bottle washing machine, where devices called cells line them up in rows of 16. Each bottle tilts and enters the washer neck first. Inside, a combination of powerful water jets and soap remove dirt and germs. Then water jets rinse off all traces of soap. As they exit, they pass in front of a neon inspection light. Workers pull any problem bottles off the line. Now the bottles head to the same bottling machine as before, only now it's been adjusted to fill each bottle with 300 milliliters of drink, in this case, orange soda. This factory takes a sample from each production run for quality control testing. The lab technicians check such things as the dilution ratio of syrup to water, the carbonization level, and the airtight seal. They also analyze the purity of the drink and container by running the sample through a paper filter. They put the filter into a petri dish containing the nutrients needed to grow microorganisms. Then they incubate at a precise temperature and observe if any bacteria grow. These glass bottles have old-fashioned bottle caps, not the twist caps the plastic bottles have. As each cap drops down onto a bottle, the machine squeezes it tightly, creating an airtight seal. Once the bottles are filled and capped, they go into shipping cases. A glider rocker combines the back-and-forth movement of a traditional rocking chair with the gliding motion of a swing. Parents often buy them to rock their infants to sleep or soothe them while feeding. Other models are designed for people who like to rock and glide while having a conversation, reading a book, or watching TV. Glider rockers come in a few different styles. Some are made of solid wood with a variety of cushions. Others have a metal frame that's partially or fully upholstered. The first step is to cut the dried wood to the required dimensions using laser and computer-guided saws. The species this factory uses for its wooden models are maple, oak, and ash, hardwoods known for their strength and durability. Then a computerized industrial router shaper forms tenons. A tenon is a projection on the end of one piece that fits into a cavity called a mortise on another piece. Another shaper profiles the seat frame pieces, 4 at a time. Workers glue each tenon and mortise together by hand, then clamp the joint. Once the glue cures, these joints will be virtually indestructible. With the glue dry, the seat frame moves on to the next phase. Another automated router shaper gives it the final contour. Next, they smooth the surface of the wood using successively finer sandpapers. Now they bore a series of holes for attaching the armrest and back of the chair. Precision is critical here. They assemble those pieces in a custom-made assembly jig to ensure their exact position and angle before screwing them in place. Now they attach what's called the multi-position mechanism. This enables the glider rocker to lock in 6 different comfort positions. This part, called a trammel, controls the angle. Ball bearings located at the top and the bottom of the chair's arms are key to a smooth gliding motion. Secured solidly, they'll last a lifetime. Workers assemble the parts that make up the rocking gliding mechanism. Finally, they slide it under the seat frame and attach it to the multi-position mechanism. It's critical that the fit be precise for the chair to operate properly. Meanwhile, work is underway in the upholstery department. There are many different styles and colors of fabric available. Workers stack several layers of seat cover fabric for a given model in a pile to cut several in one shot. The pile lies on a textured rubber mat held steady by a vacuum press so it won't move while the computerized cutter does its work. After the pieces are cut, a seamstress sews the zippered seat cushions. Another vacuum press temporarily squashes the seat cushions, enabling workers to insert one in each cover. The cushion isn't a simple block of foam. Rather, it's a triple-decker sandwich composed of 2 different densities of foam glued together with a multi-layer polyester fiber. The fiber gives the cushion more depth and smoothness. The different foams maximize comfort and durability. The plastic wrapping has no structural role. It's merely part of the vacuum system. Relaxing in a glider rocker can be a very soothing experience. Picture yourself in front of the fireplace, legs resting on a gliding ottoman, relaxing your back after a long day, reading, listening to music, or just daydreaming. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.com.